Hello, this is Mr. Cole. We're going to have a look today at the idea of similarity. We've got here a shape inside a shape, and these two shapes are similar, which means that all the corresponding lengths are in the same ratio. So I'm going to start just looking at the 24. Actually, I'm going to put it this way around. 20 over 24. So that's this pair of corresponding lengths that I know. That is in the same ratio as x and 30, and also y and 36, and also z and 26. Notice I'm always putting the same shape on the top. So in this case, I've put the smaller shape on top and the measurements for the bigger shape on the bottom. Right, so to work out what x, y, and z are, first of all, I'm going to simplify this ratio. So they both divide by 2. They also both divide by 4. So the simplest I can make this is 5 over 6. That's the same fraction as 20 over 24. Now that's also the same fraction as x over 30. So this one's quite straightforward. The denominator's been multiplied by 5. I can times the numerator, the top, by 5 as well. So I get x equals 25. Okay. Next one. Again, I'm going to start with 5 over 6 equals y over 36. Here I've times the bottom by 6. So I'm going to times the top by 6, and 5 times 6 is 30. Right. Try to do the same with the next one. We've got 5 over 6 equals z over 26. Right, not so obvious this time. 6 doesn't just times by a whole number to get 26. So what we'll do is we'll do a bit of algebra. We'll get z on its own. And the way I'm going to do that, I've multiplied this side by 26. So I'll do the same over here. 5 over 6 times 26. And let's do it here. 5 over 6, 6 times 26. Enter. And I can get my calculator to put that as a fraction. There we go. So it's, z, let's write on here, z equals 65 over 3. Okay, so you can see when it works out as a nice, when you can see an obvious multiplication, you can just do these mentally. If we can see that 26 isn't a multiple of 6, then we use a bit of algebra to get z on its own, and we can use our calculator to help us if we need to. Okay, right, let's have a look at another one. Here we are. This one's a bit trickier because the triangles are similar, but they're not the same way up. So we need to look for our corresponding lengths. And here we can see, we know the one that's opposite the 64 degrees. So that's 60 is corresponding with that 48. They're in the same position relative to the angles. Okay, so again, we're going to do our 48 over 60. Let's try to simplify that. What can we divide by here? Let's do it slowly. Divide by 2, we get 24 over 30. Divide by 2 again, 12 over 15. Divide by 3, 4/5. So that's the ratio of our sides. So now, which one's corresponding to the 14? Well, it's the one between the right angle and the angle of 64. So that's x. Okay, so let's get a different color to show that nicely. X and 14 are corresponding. So x over 14 is the same as, hang on, I need to be a bit careful. This 5 came from my 60, came from my biggest triangle, so I'm going to put it on the top. 5 over 4. Okay, we could also have done, if we started with 4 over 5, we could have said that that was equal to 14 over x. So it doesn't matter which way round we go, as long as we're not mixing up the small and the big. So this is the, on the top, we've got the ratio from the smaller triangle. So that 48 simple down to the 4, and then the big triangle on the bottom. Okay, so we're going to do a bit of kind of cross multiplying here. I'm going to, well, no, actually all I'm going to do is get x on its own by timesing by 14. We can use a bit of mental maths here. Okay, they cancel out. So we end up with 35 over 2 is the value of x. If we want to find y, actually our idea of similarity doesn't really help here, but we do have a right angled triangle and we know 2 of the lengths. So let's get another colour again. What we'd have to do to find y here is use a bit of Pythagoras. So x is 35 over 2. That squared add 60 squared equals y squared. And then y is going to be the square root of that answer. Okay, so let's go over here. In brackets, 35 over 2 all squared, add 60 squared equals, all right, and that, so if I do square root of my answer, I'm going to get that number there. So 62.5 is my longest side, and there's no, that's just units. We don't actually, and this one as well, units. It doesn't give us centimeters or inches or anything. Okay, that'll do for now.